Assalamu alaikum. This is Abu Bakr Ali, and we are going to discuss reflection and total internal reflection. Okay, this is the most important topic in the light section. Okay, and this is the topic that I feel mostly students confused, and this is the topic जिसमें आपके पास मोस्टली फार्मूलाज वेव्स के चैप्टर के इसी टॉपिक में इंक्लूडेड है, राइट? So that is very crucial and very important for exam point of view in IGCSE. So let's start from the basic terms. First, we will try कि हम कुछ चीज़ों को terminologies को define करें, those we are going to use later on, and then we will move forward. Okay. So starting from the definition of reflection. What is reflection? Basically, when light moves from one medium to another medium, its direction will change, right? So that phenomena is called the reflection. So we can define simply as bending of light when it passes from one material or the medium to another. That is called reflection. Okay, it can be defined as the change in speed when it moves from one medium to another. It can also be said as change of wavelength because the speed, direction, and wavelength, they're all changing, right? When it enters from one medium to another. What will remain constant? Frequency will not change. Frequency of the wave will remain same. Okay, so that is very important. Okay, so the next term that we use is the normal. But the normal is imaginary line that we draw perpendicular on the boundary. Okay, that is for the reference. Normals हम क्यों draw करते हैं? Just to measure the angles. Incident angle, reflected angle, they are all measured with respect to the normal. Okay, so it's the reference line and it's the imaginary line. It does not exist in actual. Okay, so what the incident angle is? Incident angle is between the incident ray and the normal. Okay, as I mentioned कि आपके पास जो भी एंगल्स मेजर किए जाएंगे वो कहाँ किए जाएंगे with respect to the normal, right? And same as refraction angle is angle between the refracted ray and normal. Okay, so let's suppose we are going to discuss two different cases. First case, when light move from less dense to more dense medium. Okay, this thing that I'm representing here, this is, let's consider it's the glass, and above this medium is, let's consider this is the air. Okay, so it's moving from less dense to more dense. So air is less dense, it's the gas, right? And glass is a solid. Solids are more dense than the gases. Okay, so light can incident at any point. So let's suppose the light is going to strike at this point, like this. Okay, so this will be the incident ray. Okay, so it's incident at this point. So this is a perpendicular line on the boundary of the two mediums. This perpendicular line will be called as normal, right? And the angle between the normal and the incident ray is called incident angle. Okay. So what the rule is, whenever a ray of light enter from less dense medium to more dense medium, it will bend towards the normal. Okay. In actual, the property of light is it always travel in a straight path. So in actual, it should travel like this. But it's not moving straight, it's bending towards the normal. Okay, so it that is what happened when it enter into the more dense medium. Okay, so this is the refracted ray. It bend towards the normal, and this thing will be the refracted angle. Okay. Yeah, so now let's see the other case. Other case can be that the light is traveling from the dense medium. It's mean it is already in the glass and it's moving towards the air. So this is the incident ray now, and I have to draw the normal first because normal is the reference line, and this is the normal. Okay, it's perpendicular to the boundary. This was the boundary of the two mediums. Okay, okay. So now what will happen when it travels from more dense to less dense medium? It will bend away from the normal. Okay, so this is the refracted ray. So that is the rule that you have to keep in mind. In actual, this light should move straight, but because of the change in medium, it will bend away from the normal, right? And incident angle is this, and refracted angle is this in that case. Okay, incident angle is between the incident ray and the normal, and refracted angle is between the normal and the refracted ray. Okay, so these are the two cases that you have to keep in mind when the ray of light will bend towards the normal and away from the normal in the reflection. Okay, next, a very important concept is the critical angle. Okay, what the critical angle is basically, first we have to look at the simple reflection. We know that whenever light moves from more dense to less dense medium, this region below we are considering this is the glass, and the above this black color region is, let's suppose it's the air. Okay, so light is moving from more dense to the less dense. This is basically the condition for it that we will discuss later on in detail, okay, in this same video. So when light moves from strike at this point, there will be a phenomenon of reflection. It will bend away from the normal, it will move like this. Okay, so this will be some angle. It can be angle of reflection. Okay, now let's suppose if I increase this angle of incidence, if I now incident angle light at this angle, now it will make this angle, right? This will be the theta 2. That is greater than the previous angle. So the reflected ray will also bend more than the initial one, right? So it will bend like this. And there is a possibility if I keep on increasing the incident angle and the reflected ray will keep on bending towards the normal, it will start moving parallel to the boundary. Okay, this is also a possibility. So when this happens, let's suppose if I take some angle at some angle of incident, the ray of light after reflection start moving parallel to the boundary like this. Now this is the theta, let's suppose, theta 1. This is the refracted angle, and if you see this is the 90-degree angle. That is basically refracted angle, right? So refracted angle is 90. This is the incident angle, okay? And this incident angle is called, what it is called? Critical angle. So we can define critical angle as angle of incidence at which the refracted angle is 90 degree. Or you can say the angle at which the ray of light after reflection start moving parallel to the boundary. Okay, so don't be confused between the angle of incident and reflected angle. Critical angle is the incident angle. Okay, critical angle is the incident angle, but it is the angle at which the reflected angle should be 90. Ray of light should move parallel to the boundary. Okay, and for this angle, the relation we have is n is equals to 1 over sine c. This relation we will use. What is n? This n is the refractive index of the medium, and c is the critical angle. Its mean the critical angle of the medium is changed with respect to the refractive index. For different materials, critical angle is different. Okay, and that defines the property of the medium. Like for the diamond, for the glass, for the water, the critical angle is different. Okay, so at that particular angle, the ray of light after reflection start moving parallel to the boundary. Okay, now let's suppose what happens if I further increase this angle of incidence. So the light is already bended and it's moving parallel. So if I further increase, it bend again and it move back into the same medium. Okay, so this phenomena that I'm going to draw here, now this is, let's suppose this angle, let's call this incident angle is C for the critical angle, right? So now I'm going to strike the light at some particular angle, and what I am saying that this angle, incident angle, that is greater than the critical angle. Now what will happen? The light will bounce back into the same medium. Okay, this is called total internal reflection. Okay, because light is totally reflected back into the same medium. That was the incident ray, and it will follow this rule of reflection. And what is the rule of reflection? That this angle and this angle they should be same. Okay, so this is the total entire reflection, and the concept of critical angle basically. Okay, so next thing that we are going to discuss that how the ray of light behave when it passes through the different mediums. Like we are starting from the first shape that is a rectangular shaped glass. So let's suppose the light is moving from this point. It's going to strike here. So how it will behave? To check it first, we have to draw the normal that is perpendicular on the boundary. Okay, so how you can draw it with a scale? Let me do it for your convenience one time. So you have to take the scale. There is my scale, and you have to place it here at this point where the light is striking, right? And it should be, if you see at the middle of the circle, there is a degrees. So it will be now it's perfectly perpendicular to the boundary, right? So I have to move it a bit. Where is my? So now this is perpendicular, okay? So I have to draw a perpendicular line like this. That is basically the normal, okay? So this is the normal. So now the light is moving from less dense medium to more dense medium, right? So less dense, this we are considering air, and this thing is the glass as mentioned here. So it will bend when it moves into the dense medium, it will bend towards the normal. So it will move like this, tilted towards the normal, okay? And it's then move straight and strike at this point. Now it's striking at this point. Now again I have to draw the normal. Now let's take the scale again and put it here, and you have to draw a perpendicular line at this point. That will be the normal at this point. And now basically the light is now moving from glass into the air. So you have to use the second rule. Now it will bend away from the normal, right? So it will move from this point like this. So this is the final path of it. So this will be the angle of refraction, this will be the angle of incidence. So that is the path of the light when it moves from glass. It will emerge like this. Okay. I'm not making it exactly the angles are, but uh, I'm just showing the path of the light. These are the approximate angles, right? And you don't have to measure it in the exam as well. Okay, so next is let's suppose if the light is going to pass from semicircular block. Okay, so light is incident at a particular point. Let's suppose this is the point. We first have to draw the normal. I'm making the normal here. Okay, this is the perpendicular line almost. And now the light is again moving from air to glass, so it will move towards the normal, right? So it will be moving like this, and it's going to strike at this point. Okay, so this is the incident angle, this is the reflected angle. Okay, so when it strike at this point, if you observe it closely, this thing is making angle 90 degree at here. Okay, so whenever light strike the boundary of the medium perpendicular to it, it will move straight through it. It will not change its position, its direction. Okay, it will pass straight through it. That is the rule that you have to keep in mind. Next is for the glass. If you see at this point, light is exactly striking the glass with the angle of 90 degree. It will pass straight through it, and the shape of the prism is like this. If I make the normal here, the normal will be this line. This is making angle almost 45 degree, and critical angle of glass is around 42. So there will be a total internal reflection, and with the same angle, almost same angle, it will reflect back and it will move like this. Again, when it hit this point, I have to draw the normal here. The normal will be like this. This angle is again almost 45 degree, and it will again total internal reflection. It will bounce back into the same medium with the same angle, and at this point it's 90 degrees, so it will move straight through it. Okay, so this is the complete process for the light that is moving in the prism that way. Okay. Okay, so next thing is refractive index. The refractive index basically defines the property of the medium, that how much light will be changing its speed or its wavelength, or how much light will be bended when it moves into that medium or out of that medium. Okay, so refractive index can be defined as the ratio of speed of light in vacuum and the speed of light in that medium. Okay, it's the ratio of it. So the maximum speed of light is in the vacuum. That is 3 into 10 raised to power 8. That is mentioned here, right? Meter per second. And when it enter into the material, its speed will decrease. So if you find the ratio of it, you can tell the refractive index of that medium, right? And refractive index is the unitless. Why? Because it's a ratio of same quantities, so units will be cancelled out. Okay, so we don't have any units for refractive index. Next relation for the refractive index is we can find it from the ratio of sine of I over sine of R. What is I? I is angle. Which angle? Angle of incidence. And same as R is the angle of reflection. Okay. So this thing n cannot be written as n is equals to I over R. That is entirely wrong. That is a very common mistake on the student end. Okay. You don't have to do this. That is the wrong way. This is the correct way. It's sine I over sine R. Okay. And you can find the value of sine from the calculator easily. So these are the two relations for the refractive index. We have studied one more relation above, that was the relation for the refractive index and the critical angle. Okay, that was 1 over sine c. That is specifically for the critical angle. And for the normal refraction case, you can use either this one or this one. And you have to keep in mind this c is the speed of light. The above given relation was that c was the capital C. It was for the critical angle. Okay, critical angle is not fixed. It will change from material to material, but this c, speed of light in a vacuum, will remain constant. 3 into 10 is to power 8. Okay. Okay. So the next thing that we have to discuss is total internal reflection. We have discussed it early. Now we are going to define it and going to discuss the conditions for it. How we can define it: when a light ray hit the surface between two materials and reflect completely back into the original material, that phenomena is called total internal reflection. Okay. So what are the conditions? There are basically two conditions. Those need to be fulfilled for the total internal reflection. First is light must be passing from the dense medium. Mean it should be traveling from glass to the air or from water to the air. If it is moving from less dense towards the more dense, the total internal reflection is not possible. Okay. So that is the first condition. Second condition is the angle of incidence must be greater than the critical angle. Otherwise, the total internal reflection will not happen. Okay. So this is this is the comparison between the simple reflection and total internal reflection. Okay, let's first see the simple reflection case. Let's suppose this is the incident ray of light that is hitting at this point, and when it incident on this point at the boundary, its angle is less than the critical angle, so it will refract, it will bounce back into the second medium. Okay, and a part of it will be reflected back. Okay, so it is refracting into the second medium, and part of it will be reflected into the same medium. Okay, but that is not a total internal reflection. Why it's not? Because it's not totally reflected back. Part of it is going into the second medium. There is one more difference between the total internal reflection and this thing. This reflected ray will be stronger. This will be the weaker. The reflected ray will be weaker. There is a very less portion of the light intensity that will bounce back. Okay, so that is a partial reflection, you can say. Most of the part of it will move into the second medium. That is normal reflection. In each and every normal reflection, part of the light will bounce back. Okay, but that will be less intense than the part that is reflected, that will go into the second medium. But in case of the total internal reflection, when we met both the conditions that light is moving from more dense to the less dense, and the incident angle is greater than the critical angle, then the light will totally bounce back into the same medium. Nothing will move into the second medium. That is the reason why we use the word total, because light totally refracted back into the same medium. Okay, so that is the difference between simple refraction and total internal reflection. This total word indicate that no light will bounce into the second medium, all of it will bounce back. Okay, and the main key point is in simple reflection, partially light will bounce back and some of the portion will move into the second medium. This will be more intense, and in this case, this will be less intense. Okay, so that is a important point to keep in mind. Okay, So that's all for this topic.